Welcome to Lab to Lecture. In this video, we're solving chemical energetics questions, breaking down enthalpy and energy changes in reactions. Let's get started. Question 1. This is a typical chemical energetics question, giving you a chemical equation and asking you to calculate the total energy of the bonds broken of the reactants and the total energy of the bonds formed in the products. Point A. Energy needed to break bonds. We may use the verb needed, we may use the verb required, or the verb taken in or used. So here in the reactant side, we have 5 bonds between carbon and hydrogen. This is 1, 2, 3, 4, and 5. So the total energy for bond breaking is 5 times the bond between carbon and hydrogen. And we have one bond between carbon and carbon. So plus 1 times carbon-carbon bond. And we have one bond between carbon and oxygen. So plus 1 times the bond between carbon and oxygen. One bond between oxygen and hydrogen. So plus 1 times the bond between oxygen and hydrogen. Finally, we have a double bond between oxygen and oxygen, and that's repeated 3 times. So plus 3 times the bond between oxygen and oxygen. If we plug in the numbers from the table, we're going to have 5 times 413 plus 347 plus 359 plus 464 plus 3 times 498. And if you add up all the numbers, you're going to get 4,728 kilojoules. So the final answer is 4,728 kilojoules. Next, energy released when bonds are formed. We may use released, we may also use the verb given out. So you know that when we have bond making, energy is released. And the bonds here are between carbon and oxygen twice in one molecule. But we have 2 overall molecules. So we have 2 times 2, the bond energy between carbon and oxygen. So 4 times the bond between carbon and oxygen. Also, we have the bond between oxygen and hydrogen repeated twice in one water molecule, but we have 3 water molecules. So we're going to have 3 times 2, which is 6 times the bond energy between oxygen and hydrogen. That's going to be 4 times 805 plus 6 times 464. This adds up to 6,004 kilojoules. So the answer here is 6,004 kilojoules. The last point, he's asking to find the overall energy change of this reaction. So as you know, the overall energy change or enthalpy change is simply the energy of the bond breaking minus the energy of the bond. 4,728 minus 6,004, and that gives us a minus 1,276 kilojoules per mole. So the final answer is minus 1,276. In this type of questions, he may add a point asking if this reaction is exothermic or endothermic, simply you have to look at the sign. If it's negative, exothermic; if it's positive, endothermic, and then you have to explain, as we're going to practice in a minute. Question 2. This is pretty much the same type of question, but just we have one extra point. In the first point, as usual, he's asking for bond breaking energy. So here we are calculating the energy of the bond breaking. Once again, we have three bonds between phosphorus and chlorine in one molecule. So we have 3 times the bond energy between phosphorus and chlorine. And we have one bond between chlorine and chlorine. So we have one bond between chlorine and chlorine. So 3 times 326 plus 1 times 243, and this adds up to 1221 kilojoules. So the answer here is 1221. Next, energy released. So he's asking for the total energy of the bond forming or making. So bond making. We have here 5 single bonds between phosphorus and chlorine. So it's 5 times the bond between phosphorus and chlorine. That's 5 times 326. And that gives us 1630 kilojoules. So the answer here is 1630 kilojoules. The last usual point, he's asking to find the overall energy change of the reaction. And as we said before, you have to just take the difference between bond breaking and bond making. So delta H for the reaction is going to be from here 1221 and there 1630. So 1221 minus 1630, and that gives us minus 409 kilojoules per mole. So the final answer is minus 409 kilojoules per mole. Now, the next extra point, he's asking to deduce whether the energy change of the reaction is exothermic or endothermic. And also he's asking you to explain, and that's for 1 point. So you have to tell me exo or endo, and at the same time you have to give me the reason for your answer. So the reaction clearly exothermic because we have a negative sign here. So the reaction is exothermic. And the reason behind that, because the energy change, delta H, or energy change, is negative. Now, here I'm going to give you the golden rule that we're going to apply in this type of questions to explain why the reaction is exothermic or endothermic. And I really advise you to write it after me. It's very important, and we're going to use it a lot today. So we have the mnemonic device mexo-bendo. It means making bonds is an exothermic process, while breaking bonds is an endothermic process. And you have to remember that exothermic means negative, endothermic means positive, because energy is always released in exothermic, and energy is always absorbed in endothermic. So that summarizes everything we need to know. Now, since the overall is negative, it means that left-hand side part, which is mexo, is more than bendo. It means the energy released in making bonds is greater than, because remember the negative is greater than the positive, so the mexo is greater than the bendo. So we may say that the energy making bonds is more than energy absorbed in breaking bonds. Let me tell you that this is the best ideal answer for this fourth last point of this typical question of chemical energetics. So once again, remember, an explanation question, always remember mexo-bendo, mexo-bendo. Mexo, negative, released, bendo, positive, absorbed. And you look at the overall. If it's negative, it means that left-hand side negative part is greater. If it's positive, it means that right-hand side part is greater. So you have to look whether it's mexo overall or bendo overall. Question 3 is another typical question, but here we have just one more little part, which is asking for 1 mole of ammonia. So let's go through the steps. Step 1, the energy for bond in 1 molecule of ammonia, we have 3 single bonds between nitrogen and hydrogen, but we have 4 overall molecules. So we have 4 times 3, the bond between nitrogen and hydrogen. So that's 4 times 3. 4 because we have 4 molecules, and 3 because we have, in 1 molecule, we have 3 bonds between nitrogen and hydrogen. Also, we have the double bond between oxygen and oxygen, and that's repeated 5 times. So plus 5 times the double bond between oxygen and oxygen. So it's 4 times 3 times 391 plus 5, 498. And that gives us 7,128 kilojoules. The energy of the bond making. We have the bond between nitrogen and oxygen, and that's repeated 4 times. So 4 times nitrogen and oxygen bond. And we have the bond between oxygen and hydrogen, and it's repeated twice in 1 molecule, but we have 6 molecules, so we have 6 times 2. So we're going to have 6 times 2 times the bond between oxygen and hydrogen, it's 464. And that gives us 7,916. Finally, the overall energy change, once again, when you take the bond breaking and the bond making and you take the difference between them. So it's going to be delta H for that reaction is 7,182 minus 7,916. That gives us minus 734 kilojoule per mole. Now, here is the tweak in that question. He's not asking for the overall reaction. Look here, we have overall, we have in the reactant side, we have 4 moles of ammonia reacting with 5 moles of oxygen. But he's just considering, what if we have, instead of 4, what if we have just 1 mole of ammonia? So the number that you got here is if you have 4 moles, but I'm asking about just 1 mole. It means you have to divide this overall energy change by 4 because you need it for 1 mole. So here is the twist in that question. He's just asking for a specific amount of the reactants. So the final answer is going to be minus 183.5 kilojoules per mole. This question is another typical question, and once again he is asking for the total energy for bond breaking. I'm just going to give you the answer directly because I just want to reach the final explanation part. So the bond breaking here is going to be 2,670 kilojoules, and in the next point, if you calculate the bond making, is going to be 2,610. And finally, to find the overall change, you have to take the difference between them. So delta H equals 2,670 minus 2,610, and that gives us plus 60 kilojoules per mole. So the answer here is plus 60. And I just need to reach that explanation part here. Once again, as I told you, you may have fourth point asking for the reaction, whether it's an exothermic or endothermic, and give reason or explain. Since here you have a plus sign, that's an endothermic. And that's because the overall energy change is positive. Once again, let's apply our mexobendo mnemonic device. Mexobendo. Remember, making bonds, that's M, is an exothermic process, while breaking bonds, that's B here, is an endothermic process. And always remember that making bonds, since it's an exothermic process, is always negative. Breaking bonds, since it's an endothermic process, is always positive. Energy here is released, while energy here is absorbed. Now, let's look at the overall change. Since the overall change is positive, it means that right side part here in the bendo is more than the left side in mexo. So bendo is more than mexo. So positive is greater than negative. That's why the overall is positive. So you may say the energy in bond making, which is this negative part, is less than the energy absorbed in bond breaking. So once again, the positive bendo is greater than the negative, or you may say the negative is less than the positive. So say it the way that you want, but you have to tell me about the relation between bond making, which is a negative part of the mexo, and bond breaking, which is the positive part of the bendo. So always remember, when you have explanation question, mexo bendo, negative, positive. Look at the overall, and if the overall is positive, it means bendo, which is the positive part, is greater. If the overall is negative, it means mexo, which is the negative part, is greater. And mexo means making bonds, and that always releases energy. But bendo means breaking bonds, and that always absorbs energy. So you have to refer to making and breaking bonds, and also you have to refer to whether releasing or absorbing energy. Next question. This is an energy profile diagram question. Sometimes we call it energy level diagram. Other times we call it reaction pathway diagram. So here you have the diagram already drawn for you, and you're just asked some questions. Name the energy change labeled A. So remember, from the energy level of the reactants, here we have reactants, and there you have products. So from the energy level of the reactants to the top of that hump, that's activation energy. So the answer is activation energy. Name the energy change labeled B. So from the level of the reactants to the level of the products, that difference is the enthalpy change or energy change. And guys, remember always that we have three synonyms, three equivalent words. Let me just remind you that we have the word energy is exactly equivalent with the word heat. Because heat is a form of energy, but energy is more generic. And also, they are equivalent to a more fancy term we use in chemistry, which is enthalpy. Actually, there is a very slight scientific difference between them, but for your level, you may consider all of them to be the same. So that's why in question B, you may say enthalpy change, you may say energy change, you may say heat change of the reaction. So I'm just going to pick enthalpy. So enthalpy change, which is delta H of the reaction. Next, state how the energy profile diagram shows this is an exothermic reaction. If you need to explain something in the energy level diagram, you have to look at the levels of the products and compare them to the reactants. In this situation, the energy of the products is less than the energy level of the reactants. So you may say products energy level is less than reactants energy level, or you may just say reactants energy level is higher than products energy levels. So say it the way that you prefer. So you may say the energy of the reactants is higher than the energy of the products. Next, here we have a question that asks to complete the energy profile diagram. So first you have to search whether it's an exothermic or endothermic, because that tells you whether you have the products at a level lower than or higher than the reactants. So in that situation where we have an exothermic, then you have to choose the level to be lower than the reactants level. So it could be here, and you have to just try the formula of the product, which is C2H4Br2. So that's the product that we got. And in between, we have the activation energy hump. So firstly, you have showed the product's level, and he's asking to use an arrow to show the activation energy. So remember, activation energy from the level, just make extension of the level of the reactants and then use an arrow. Always activation energy, the arrow is pointing up. And then you have to label it as E sub A, and then you have to give him a key, like tell him that E sub A is the activation energy in my diagram. And also he's asking for an arrow to show the energy change of the reaction delta H. Remember, delta H from the level of the reactants to the level of the products. You just make an extension to the level of the products and then just move from reactants to products, and the arrow has to point downward, and that's delta H. And tell him that delta H in that diagram represents the energy change of the reaction. Let's pick another question here. Once again, he's asking for the energy of the bond breaking. 4 bonds between carbon and hydrogen, 1 double bond between carbon and carbon, and 1 single bond between chlorine and chlorine. So it's going to be 4 times 410 plus 1 times 610 plus 1 times 240, and all of these add up to 2,490 kilojoules. So the answer is 2,490. Now look at this point here. He gave you the overall energy change of that reaction, and you have to notice that it's negative. It means it's an exothermic reaction because it was given to you in a negative sign. And in that step here, he's asking you to determine the energy released when bonds are formed. So he's asking you for the total energy of the bond making or forming. Remember, the equation says that the overall energy change, delta H, equals the energy of the bond breaking minus the energy of the bond forming or making. So the overall energy, delta H, it was given to you as negative 180, and the bond breaking, we've just calculated it, it was 2,490 minus the bond making, or the energy for the bond making. I'm just going to assign it here as X, and then just do the math and find the value of X. If you just calculate the value of X, it's going to be 2,670 kilojoules. So the total bond making energy is 2,670. Remember that bond making for the product side, and we know it now. In step 3, he's asking you to use the bond making energy and to calculate the energy of the carbon chlorine bond. So remember, the energy of the bond forming or making is the total bond energies for the product side. So here we have 4 carbon hydrogen single bonds between carbon and hydrogen. So 4 times the bond energy between carbon and hydrogen. Also, we have 1 bond between carbon and carbon here in the middle. So it's going to be plus 1 times the bond energy between carbon and carbon. Also, we have a bond between carbon and chlorine is repeated twice in the molecule. So this is going to be 2 times the bond between carbon and chlorine. So 2 times the bond energy between carbon and chlorine. So the energy of the bond making from the previous step is going to be 2670. That's from the previous step, equals 4 times 410 plus 350 plus 2 times the bond between carbon and chlorine, and this is the unknown here, so it's 2x. And then just you have to do the math. It's just simple algebraic equation. Just do the math and find the value of x. And you're going to find that x equals 340 kilojoules per mole. So the bond between carbon and chlorine is 340 kilojoules. Let's look at this question. We have an equation, and notice here that he didn't show the structure of this molecule carbon monoxide. He gave you all the bond energies for this equation except the bond between carbon and oxygen here in carbon monoxide. And we don't know the type of bonding. Is it a single, double, or triple bond from the equation that was given to you? And he's asking you to find the bond energy in carbon monoxide. Well, we know that the overall energy change of the reaction, delta H, equals the energy of the bond breaking minus the total energy of the bond making or forming. So delta H equals, in the bond breaking, in the reactant side, we have a bond between chlorine and chlorine. Now for the whole bond breaking part, I'm going to use large square brackets. And inside the square brackets, we have one bond between chlorine and chlorine. So we have 1 times the bond energy between chlorine and chlorine. And we have another bond between carbon and oxygen, and we don't know the identity of this bond. So I'm just going to leave it as CO. That's for the bond breaking or the reactant side. Minus the bond making or the product side, we have 2 bonds between carbon and chlorine. So 2 times the bond between carbon and chlorine plus 1 double bond between carbon and oxygen. So 1 times the bond energy between carbon and oxygen. And you have to notice that it's not the same, or it doesn't have to be necessarily the same as the carbon-oxygen bond here in the reactant side. It could be, we don't know, but let's confirm. Okay, so if you plug in the numbers, delta H was given to you as 230 kilojoules. And here is the trick in the question. Look at this hidden word here, released, released. Now, he gave you the overall change and he told you that that energy overall was released. And the overall reaction is releasing energy when it is an exothermic. So he didn't tell it to you directly, or even he didn't give you the sign positive or negative, but he told you that hidden word released. It means that amount of energy is negative. He didn't give you the minus sign before the number 230, but he told you release. It means that number has to be negative. So delta H for the overall reaction is negative 230. Now the bond between chlorine and chlorine is 240. So 240 plus the bond between carbon and oxygen, and this is the unknown. I'm just going to put it here for you as X. That's for the reactant side, minus the bond making in the product side, 2 times the bond between carbon and chlorine, and that's 400. So we have 2 times 400 plus the bond between carbon and oxygen, and that's 745. Now, the rest of the question is just mathematical manipulation. Just you need to simplify the equation and find the value of x. So let me just do it quickly with you. So if you simplify this part, if you multiply 400 times 2 and you add 745 to it, that's going to simplify the equation into negative 230 equals 240 plus x minus 1545. Now you may move that negative number to the opposite side of the equation as a positive number. So it's going to be 1545 minus 230 equals 240 plus x. And then once again move the 240 to the opposite side with the negative sign. So x is going to be 1075 kilojoules per mole. Just needs a bit of practice. Now, the next question, he's telling you that chlorine reacts with carbon monoxide to produce this gas, and also we use a catalyst. We haven't talked about catalyst so far, but the first point he's asking you to explain after telling you that the reaction is exothermic, and he's telling you to explain. We said before, remember, any explanation question, whether why is it endothermic or exothermic, remember you have to use the golden mnemonic device, mexo bendo. Making bonds is an exothermic process, and any exothermic process is negative. Breaking bonds is an endothermic process, and any endothermic process is positive. Energy is going to be released in the exothermic process and absorbed in the endothermic process. This question is 3 marks. It means it's not just enough for you to mention whether mexo part or bendo part is greater, but you have also to tell him more points. So I'm just going to start from scratch. The first point, you need to tell him about mexo and bendo themselves. So bond making is an exothermic process, while breaking bonds or bond breaking is an endothermic process. Remember, all of these ideas, I got it from the mnemonic mexo bendo. That's it. So here we have 1 mark for explaining mexo, 1 mark for explaining bendo, and finally, the final mark to tell me the relation between mexo and bendo, which one is greater. If you have an exothermic overall reaction, it means overall you have negative. So which one will win from these two parts? Is it the negative or positive part? Since overall is negative, it means the negative part, which is mexo, is going to be greater. So remember, once again, energy is released in making bonds, and energy is absorbed in breaking bonds. And in that situation, in that specific question, since the reaction is exothermic, so the negative mexo part is greater than the positive bendo part. So you may say that total released energy of bond making is more than the total energy absorbed in breaking bonds. The next point, here we have a graph of that reaction, and he is asking you once again to complete the graph. Remember, this question is an exothermic. You have to choose the level of the products to be lower than reactants, and then write the formula of the product, which is Cl2 from the given equation, and that's gas. And then you have to draw the hump of the activation energy, and then you have to extend the level of the reactants, and this is the activation energy. So that's activation energy. He told you in that specific question to use the symbol delta A, so I'm just going to stick to that symbol delta A for activation energy. And the energy of the reaction, the energy change of the reaction, is going to be from the energy of reactants to products. And he told you to use delta H. So you don't need to use any key because he already told you about the symbols to be used. The last point here, he is asking you to state why a catalyst is used. And this is just 1 mark. So you don't have to explain the role of a catalyst, because this is actually a topic 6 question. We'll discuss catalysts later on in the next topic. But since it's just 1 point, you don't have to go deeper into explanation of a catalyst. So maybe it's enough to you to just tell him that we use catalysts in general to increase the rate of reaction. To explain deeper, you may tell him that it lowers the activation energy through finding alternative route for the reaction, and that's going to come up in the next topic in detail. Once again, you have a chemical reaction, and he's asking you for the bond breaking, bond forming, and overall energy change. I'm just going to save your time, but you have to answer all of these questions yourself, and you have to check your answers and compare it with the mark scheme. I'm just going to give you the final answers here. For the bond breaking is going to be 1,425 kilojoules. For the bond forming or making is going to be 1,800. And if you take the difference between them, the final overall energy change is going to be minus 375. So that's an exothermic reaction. Now I just need to reach that final part here, the explanation part. Is it an endothermic or exothermic? Clearly, that's an exothermic. So the answer is exothermic. Remember, we chose it to be exothermic because the overall energy change is negative. And once again, remember mexo, bendo, negative, positive, released, absorbed. And then since here overall is negative, it means mexo is greater than the bendo. So the energy released in bond making is more than the energy absorbed or taken in bond breaking. That's it for today. I hope that helps. For the rest of questions and for more questions to be practiced on that topic, please send me a message or leave a comment in the comment section. I'll send you the file with the mark scheme, and don't hesitate to ask any question in the comment below. I'll be more than happy to reply to your question as soon as possible. See you next time.